Hello and welcome everyone to this virtual meetup organized by H2O.ai. My name is Ivan Trehin and I am on the marketing team here at H2O.ai. Before we dive into our topic today, I would like to say a few words about our company and what we do for those who don't know us yet. So H2O.ai was founded about 8 years ago, and we offer several platforms to make AI accessible to everyone. We are the creator of H2O Open Source, a platform that is used by nearly 20,000 organizations. And we also offer an enterprise platform called Driverless AI. It is our product for automatic machine learning, and it helps accelerate the data science workflow. So if you would like to know more about us, feel free to get in touch with us. Take a look at our website, h2o.ai. And I'm going to share a link in the chat where you can also request a free and personalized H2O intro pack. We have a guest speaker today. Hi, Andrew. Welcome.
Hi, Ivan.
Hi. So you are a strategic advisor on AI, a founder and CEO of Greenhouse Intelligence, a company that provides consulting services to help organizations maximize the value from AI. And today this session is going to be about understanding AI benefits and capabilities. So Andrew, thanks for being with us today for this exciting topic. And before I hand it over to you, I would like to go over the following housekeeping items. So in the audience, if you have any questions during the presentation, please use the questions tab, and Andrew will take some time at the end of the presentation to answer your questions. And this session today is being recorded. A copy of the recording will be available on the H2O.ai YouTube channel after the presentation is over. Now I'd like to hand it over to Andrew.
Brilliant, thanks Ivan, and it's a pleasure to be hosted by H2O for this webinar. I'll just start a little bit a detail about me. So as Ivan said, I'm an independent advisor on artificial intelligence. I do quite a bit of writing, so I'm the author of the Executive Guide to Artificial Intelligence, which was published last year by Paul Brave Macmillan. I also speak at events like the All-Party Parliamentary Group on Artificial Intelligence in the UK government. I'm a senior visiting fellow in RPA and AI at Loughborough University, a expert in residence at Imperial College London at their Enterprise Lab, and I also do writing for various magazines and journals as well. I'm also, as Ivan said, founder of Greenhouse Intelligence. So we provide AI strategic services to enterprises, and this is just a few of the clients that we have and have worked with in the past. So I think, you know, that's enough about me. This session's aimed particularly at business people. So I'm going to be explaining everything in non-technical language. If there are any data scientists and developers amongst you who already have a good grasp of technology, then I think there'll still be something in this session for you, because it'll help you understand how to articulate the benefits of your craft to the business side and other stakeholders within the business. So, you know, I think in both those technical and non-technical worlds, AI has suffered way too much hype. There's so much froth and ambition talked about around AI, and that leads to a lot of confusion and to a certain extent fear as well. So I'm here to actually make AI boring for you, and that might sound quite surprising at the beginning of a webinar that's going to be an hour long, but bear with me, because I want to really bring AI down to earth and try and get rid of a lot of that hype that's around. So I'm going to do that by asking 4 fundamental questions that I think everyone really wants to ask, but doesn't generally. So those 4 questions, the first one is, what the bleep is AI anyway? Second one, is AI everything it's cracked up to be? Then third, what could possibly go wrong? And finally, what do I do with all this newfound knowledge? So I think if we go through those and answer all those questions, I think everyone will have a much better understanding of what AI is and what it can do to help their business. So let's crack on and look at the first question there, what the bleep is AI anyway? And if you go to The dictionary, it gives you a reasonable explanation of that. It says it's the theory and development of computer systems that are able to perform tasks normally requiring human intelligence, which is fine. We're talking about the ability to mimic human thought. But he used the word intelligence. That's a little bit of a circular argument there. And if we wanted to try and define intelligence, we'd be here for the rest of the day. So another way of explaining it is through the different terms that people talk about. And this is probably about the most technical I'm going to get during this presentation. But to try and put into context some of the more common terms that people talk about, and a little bit of a timeline you can see there at the bottom. So AI, artificial intelligence, is kind of a catch-all term for everything, and that's been around since the 1950s. But in the 1950s, it was very different than it is now. And in the 80s, we developed a new branch of AI called machine learning. And as the name suggests, this is where the computer, the machine, is actually developing the models to actually do the work. And rather than being a very deterministic approach, which the previous approaches were, where you had to kind of tell the machine what to do, with machine learning, we feed it lots of data. The algorithm then develops the model itself based on that data. So we go to a very probabilistic model. So machine learning is able to give you its best guess, essentially, of what the answer to the question is. It's all around confidence levels and probabilities with machine learning. When we get into sort of the 2010s, we started to introduce this term called deep learning. And deep learning is really just a more complicated or more complex machine learning. Some of the things that are impacting AI at the moment, things like the cost of hardware, the speed of computers, the ubiquity of data, the connectivity that's around the world at the moment. All of these things are almost increasing exponentially, and that's allowed the computers to do much more. So it means we can do much more complicated things. And it's interesting now that those constraints have kind of changed on a year-by-year basis. So at the moment, the real challenge, the algorithms are really good, and there's plenty we can do. And actually, it's more around the speed and the cost of the computing power is really the biggest constraint at the moment that's holding development back. But if you look at those three terms, those are kind of the ones we talk about, but they're all part of this artificial intelligence world. But I think the best way to explain artificial intelligence is not by what it is, but what it can do. So I developed what I call an AI framework, and these next slides I'm going to build up the model for this framework. And the first thing to think about with this is there's three meta objectives that AI can do, what it tries to do. And you can see them here on the screen. So the first one is the ability to capture information. Once we've captured that information, then we want to understand what is happening. Once we understand what is happening, then we would like to understand why that is happening. So you can see there's kind of a flow here of information. And the other thing we need to bring into this framework is this idea of unstructured data and structured data. So by unstructured data, I mean things like images, sounds, free-form text. And then by structured data, things like databases, spreadsheets, web forms, etc. Okay, and in each of these boxes, there's different capabilities of AI, and I'll explain each of these very briefly now, and in the next section when I talk about some examples, I'll give you a much more detail about what they're able to do. So the first one under capturing information is image recognition, and a classic example here is the ability for AI to recognize if this picture is a dog or not, and this is actually a picture of my dog here. But it can do lots of other things as well in terms of recognizing objects or people, etc. And I'll talk a little bit more about that in a minute. We can also do a similar sort of thing with sound. So we can talk about speech recognition. And it's important to realize now all we're doing at the moment is understanding the words that the person is saying rather than the meaning or the intent, because that comes into the next block, the what is happening block. So at the moment, we're just saying, what are the words that person's saying? We use AI to be able to take those sounds and convert it into words. And then the other unstructured data format we want to do is text. Within this search capability, what AI is able to do is classify documents and extract metadata from those documents as well. So we're taking all these unstructured data formats and we're simplifying them and really making them structured so that we can then go on and process them further down the line. And then finally, with structured data, so this is things like databases, spreadsheets, etc. And you think about this idea of big data. So for example, if you've got customer buying behaviors, etc., then that's where AI is able to start to make some sense of that big data by clustering different groups together, so recognizing correlations within the groups. So once we've been able to capture that data, then we want to understand what is happening. One of those capabilities is natural language understanding, and this is where we start to look at the meaning and intent of those words that somebody's saying or writing down. And natural language understanding or natural language processing is generally used in things like chatbots. So some of you will have experienced those previously in business and when you're talking to your bank, for example. Another capability is reasoning and problem solving. And this is where you've got a particular problem to solve, and AI is very good at finding the optimum solution for that problem. So, classic example here is in route navigation, finding the optimum route to a certain space. And then the final piece of this what is happening section is prediction. So what's going to happen next? And prediction works really well with that clustering piece. So, if you think about Amazon, when you buy something on Amazon, then you are immediately put in a cluster of similar sorts of customers, and then they'll use prediction to try and predict what you're going to buy next, and present that to you. So that's all the capturing information, what is happening. When we come to why it's happening, then this is where we move out of the real world. Everything I've described so far, you can go and buy and build. When we get to why it's happening, then we're out of the real world into labs and really science fiction, because we're talking about cognition and understanding here. And this is what the brain is really good at and what AI isn't particularly good at, because everything I've described so far are very narrow capabilities, and this term of artificial narrow intelligence. So AI is very good at doing one thing very well, but it's not very good at bringing them all together. So, the brain is great at taking one concept and creating and learning new concepts based on lots of information together. AI can't do that. So for example, an image recognition algorithm can't work on speech recognition, even to the point where an image recognition algorithm that's been trained to identify pictures of dogs would have to have its memory erased and retrained if it's going to recognize pictures of cats, for example. But when people think about AI and putting applications together, then you'll tend to use a number of these different narrow capabilities to create an overall semblance of intelligence within the application. So for example, you might use speech recognition to understand what somebody's saying to you, natural language understanding to turn that into a meaning and an intent, and maybe then problem solving to actually solve the problem that person's asked for. So you're kind of stringing together these different narrow capabilities. But what this framework allows you to do is, if somebody tells you about their particular AI application, you can break it down into what it actually is, rather than trying to cut through the smoke and mirrors that they're probably putting up about how clever and cognitive their system is. So that's a very high level view of AI and the different capabilities about it. But I think it's a good framework to base your understanding on. So now we need to really move on to the next piece, which is AI everything it's really cracked up to be. And I'm going to give you some examples of each of those different capabilities to show you how it's been used in real life and in business. So the first one is an application from a company called Tractable in the insurance world. And you can see it in operation here. So the idea is if you have an accident, you then take photographs of your car and upload those to the system. And because the system knows who you are and what car you have and what that car should look like, it can then compare those with the photographs you've taken and try and identify where the damage is. And you can see here, it's able to assess that damage, and it's an American system, so it's using words like fender rather than wing and bumper, etc. But it's able to look at those and assess whether the part of the car needs replacing or whether it needs repairing. And then, although I haven't shown it in this particular clip, you can then get a quote for the repairs or whatever is required for your car within minutes of you having that accident. So from a customer service point of view, it's very, very fast. And from a, from the insurance point of view, you'll getting to the claim processing much quicker than you would do before. Other applications of image recognition, we can use it in health services. So these are brain scans, and the AI is identifying different regions of the brain and can look for anomalies where there's regions that are different than they should be. And we've also seen this used in X-rays of lungs, so we can identify potentially cancerous tumors and things like, the eyes, images of eyes to identify things like macular degeneration, etc. So some very strong benefits from AI from using image recognition. But AI also has a dark side with image recognition, and that's with facial recognition. And this is being used in public. The Metropolitan Police here in London use facial recognition at the moment. My personal view is that the technology isn't accurate enough yet to be used in the public, and I think it's a breach of our civil liberties. And even we've seen in South Wales where somebody challenged the South Wales Police on their use of facial recognition. The police lost that case by appeal recently, which probably has some beneficial effects for the use of facial recognition across the country, obviously depending on your point of view. So that's image recognition. If we then move to speech recognition, I think everyone's kind of had experience of speech recognition, from whether it's Siri or Cortana or Alexa, whatever it is, to varying degrees of success. But in kind of mainline business, we've seen some really good examples of it. And this is an application from a company called CallMiner, which the AI listens in to the contact center calls that are coming in, and then can identify where there's risks or problems with those calls. And you can see it started to grade them either green, amber, or red, depending on what the customer's talking about. So you can see, for example, some of those yellow ones, there's been a refund request. A mini Miranda failure is, again, it's American terminology, but this is where the agent has forgot to tell the caller that the call is going to be recorded. And then there's some red ones there where you see somebody's threatening legal action as well. So if you're the supervisor of that contact center, you can see immediately where the problems are, and either you can intervene and help the agent out, or you can use this as the basis for training. And it also listens into what the agent is saying as well. So is the agent expressing enough empathy to the customer to help solve their problem? Another example, this time in investment banking. So Deutsche Bank used speech recognition for that when their investment bankers are doing deals with their customers. And these deals are very big deals. So Deutsche Bank wanted to understand where there was potentially fraud or non-compliance in those deals. And previously, if they, before AI came in, they would listen to a sample of the calls from each of the dealers and try and identify any signs of fraud or non-compliance. But with AI, what the AI is able to do is listen to every call that happens, a recording of every call, and listen for the patterns that would suggest there is fraud or non-compliance in that. So only the ones where there's a confidence level of potential fraud or non-compliance are the ones that then go to the compliance department, and they will listen to them and then take the appropriate action from there. So the amount of money that goes through Deutsche Bank every day for these deals, you can imagine, is it's going to be billions of dollars. So the saving for them, the benefit to them is huge within AI. And I think that's a really important point to understand, is that AI is more around just labor arbitrage. There's lots of other benefits around risks and mitigation that will deliver orders of magnitude greater value than just saving some people. When we move to search, so this is when we're looking at text. So legal firms and large legal departments use it to analyze their contracts. Contracts are a good example of semi-structured documents where, although there's lots of verbosity in terms of the words that are written, there's lots of still structure within that contract because there's a title, there's parties, there are termination dates, there are values, there are limits of liability, etc. So what the AI is able to do is read through all the contracts and extract those relevant bits of information from that and put it into whatever the system of record is for that business. So what that business then has is a very good understanding of the risk portfolio of their contracts. And if anything changes or whatever, then they can very quickly go to the right contract within that. If you want to do that manually, then you'd have to read through everything, and it's quite a long process as well. So structured or unstructured or structured, semi-structured documents like contracts and even invoices, etc., you can use AI to extract that information very efficiently. For unstructured text, a good example of that is with Virgin Trains. Although they recently lost their license now, Avanti, what they used to do was, if you emailed Virgin Trains, your email was read by an AI system, and it was used to then prioritize that and forward the email to the, excuse me, the right person within the organization. So, for example, if you emailed saying, you know, I was on the 1256 from London to Manchester yesterday, and the Wi-Fi wasn't working, what are you going to do about it? Then that email will be read by the AI. It would classify it as a complaint. It would extract the relevant information. So this is a complaint about Wi-Fi. It's about the 1256 from London to Manchester. And then it can start to validate some things like, was there a train at that point? Did other people complain about Wi-Fi on that train, etc.? So then it can prioritize it and send it to the right person, or, you know, RPA robot within the organization to deal with. So very good from a customer service point of view. The customer gets immediate channeling of their emails to the right person. Another way that search can be used, and you know, if you take a recent example with COVID-19, it's able to look through lots and lots of research and try and look for themes within that research. And there's been lots of research published on COVID-19. Recently, hundreds of thousands of documents. So being able to find the themes and commonalities between that is very important. So we can use AI to pick out those different things and build, as it's shown here, like a knowledge map of the relationships between these different terms within the documents, and that can be useful for finding information very, very quickly. So when we look at, so that was all the unstructured data. Going back to the structured data, then we talk about clustering. If you've got a very small amount of data, the human brain can generally pick up on the themes and patterns within that. And you know, if you think about the 2 or 3 features, you can start to think about, you know, the human brain can manage that. But as soon as you get into many more features, and you know, this example here, there's 784 different features, it's impossible for the human brain to cope with that level of information and find the patterns and the correlations within that. So this is where AI comes to the fore. This particular example you can see here, it's actually used image recognition to look at handwritten numbers, and it's able to then cluster those into different groups. And it depends on the confidence levels of how it thinks that, you know, that's a number 5, that's a number 9, etc. And you can see, you know, the different groups that it's created out of that. So that's very useful, and particularly, as I mentioned earlier, within prediction. So you can use those clusterings to then predict what's going to happen next. And an example from my own work is with a couple of not-for-profit organizations that I've worked with, where we've used AI to help predict donors' propensity to donate. And you know, particularly at the moment, charities have been badly hit by COVID, so bringing in fundraising is really, really important to them. So what they want to do is spend less money, or as little money as possible, on the fundraising, but target it as best they can. And AI allows them to target only those customers that have a very high probability of donating, and ignoring the ones that aren't going to donate at all. So it saves them money in terms of, you know, the flyers that they send out to people's houses, etc. as well. So a good example of prediction in that point of view. And that prediction style uses correlation. So you're correlating different people, but also you can use it for looking for anomalies as well. So where doesn't it correlate? And PayPal uses this approach to identify fraudulent transactions. So their as somebody's paying for their goods, their product on using PayPal, then it uses AI to try and predict whether it's a fraudulent transaction or not, and can do that in almost real time. And if you look at the numbers out of this, their fraud rate is only 0.32% of their revenue, and the industry standard for other merchant services is 1.32. So they've gone 0.32 against a benchmark of 1.32. And again, if you think about the amount of money that goes through PayPal every day, that reduction means a huge amount of lost revenue that they're saving by using AI. But it's not just kind of big data that we can use to do predictions. We can actually do it with more esoteric things as well. So as this says, this is the European Court of Human Rights. And what some academics did a few years ago was look at all the different features of the cases that go through the European Court of Human Rights, and try and predict the outcome from those cases. And they did this, and they modeled it, and they were able to predict the verdicts to an accuracy of 79%, which is pretty good. And although it's not 100%, it does show that even with something that people might think is quite sensitive, quite esoteric, quite opinionated, that AI can still do a really good job of predicting those outcomes there. When we move to natural language understanding, so we're in this what is happening group of capabilities now. I said it's generally used on chatbots, conversational AI. And when I advise my clients, when I talk about chatbots, I say, if you're going to do a chatbot, you need to do it really well, or don't do it at all, because it's a very quick way of ruining your reputation as a company if you have a bad chatbot. And a really good example of a great chatbot is one called Do Not Pay, which somebody developed to help people who get parking tickets who don't think they should have got a parking ticket. It works really well because it's a very defined, focused application for that chatbot. So you know exactly what it's going to do. It's not trying to do too much. People understand the scope of it. And what it does, it goes through, asks you a series of questions in natural language. You can answer in natural language as well, and then it gives you a verdict of whether you got a good case, then go to your local authority to challenge your parking ticket or not. And it actually provides you with template letters, etc. So a very good example of using natural language understanding within a chatbot. At the other end of the scale, you've got things like IPsoft's Amelia. So the previous example, the developer would have had to have built those dialogue flows in the application about how each one progresses through. What IPsoft have been able to do is have a chatbot which learns from a corpus of information. So for example, you could feed it a section of Wikipedia, and it would read that and understand and build that knowledge graph of that information, and then be able to answer questions using natural language based on that and that information. And interestingly, you can see here the bit on the right hand side with where the chat is going on is the really important and the clever bit. The bit on the left, the avatar, is pure window dressing, and I think this is where AI can sometimes get a bad name, where people think it's trying to do more than it actually is. And I think the only purpose it serves, if you like talking to rather creepy women, then it helps. Otherwise, actually just focus on the chat bit on the right hand side. Problem solving, I think, is a really interesting area for AI at the moment, and the best way to explain this is with the power of Space Invaders. And what you see here is an AI playing Space Invaders, and this was being developed by DeepMind, a preeminent AI company based in London here, owned by Google. And the DeepMind didn't actually train the AI to play Space Invaders. All they did was say, to the AI, maximize that number in the top left-hand corner, and you'll get rewarded for that. I score as many points as possible. So at first, the gun, didn't do anything. It'll get shot. That didn't achieve its objective. So then maybe it hid behind the barriers. but it's not getting shot, but it's not scoring any points. But if it moves outside the barriers and starts shooting the Space Invaders, then it starts to score points. It's getting closer to its objective, so it starts to get rewarded. And if it shoots the big red guy at the top, then it gets even more points. So through this kind of extreme trial and error, it learns how to play Space Invaders without actually being taught. And it gets better than a human being at playing Space Invaders. And DeepMind took this approach, and some of you may have heard about this in the news a while ago, where they taught or trained the AI to play Go. And Go's a board game. It's based out of Asia, but it's a very complex game. It's on a 19 by 19 board, which means that there's more possible moves on a Go board than there are atoms in the universe. So very, very complex. But what DeepMind were able to do is show the AI lots and lots of games of human versus human playing Go. It learns kind of the basic concepts, and it starts playing itself, and very quickly becomes better than a human at playing Go. And this is the game that they set it against Lee Sedol, who was the best player in the world at the time, who they beat 4-1 in the end, and has since gone on to better things. And it's not just games as well, though. We can take the same approach of reinforcement learning and to look at wargaming exercises within businesses or negotiation. And a good example in kind of the very real world is the city of Pittsburgh in the US, which use this optimization approach on their streets. So they put lots and lots of sensors in the roads and in the traffic lights, etc., to monitor the traffic going through, and they used this to optimize the traffic light flow through the town. And what they found, they were able to reduce travel time by 25%, traffic stops by 30%, wait time by 40%, and overall emissions by 21%. So a very good outcome from AI, very practical use for AI within that area. So that's lots of good, I think, really good examples of how AI is being used today within business. And you might think, great, where do I get an AI from? But the next thing we need to consider is that third question: what could possibly go wrong? And I'm going to pick up on three of the main ones here. The first one is the black box problem, which some of you may have heard of. And this the idea that the AI can't explain the decisions it's made. And it goes back to this idea that we're feeding it lots of data, and it's using that data to come up with decisions. So if you're applying for a loan, for example, and that loan is assessed by an AI, and your loan is rejected, and you say, hang on, why was my loan rejected? It's very difficult for the AI to come back, or the company to come back and say, well, you're rejected because it's where you live, or your salary, or your age. It's going to be a mixture of all of these things based on this whole mixture of all this data that is being fed in the past. So if you're a regulated industry, this explainability is really, really important. Now, there are ways to overcome this. There's a broad rule of thumb: the more complex the algorithms you use, the more opaque the algorithm is going to be. So if you want greater transparency, you can use simple algorithms, but you may lose some of that accuracy. But actually, even over the last year or so, there's been techniques developed, actually AI techniques, to help understand AI, where they essentially reverse engineer the answer that the AI come up with to identify those areas that have been influencing the decision made. So there are ways around this, but it's very important to understand and appreciate that you can get into this black box mode and not be able to explain the decisions that are being made. Another big risk around AI is building in bias. And just to give you a good example, so the faces you can see in this slide here, a small sample of a bigger database of 13,000 different faces it's called label faces in the wild, and it was used by companies like Google and Facebook and Baidu to train their facial recognition algorithms. And although this is only a small sample that you can see here, I think you can immediately see the problem that we've got, in that most of the faces are white and most of them are men. And actually in the full data set, 83% of the photos are of white people, and nearly 78% are of men. So what that means is if you are a woman of color, for example, and you're using the system that's been trained on this, it's going to be less accurate than if you're a white man. And what AI can do very easily and sometimes unconsciously is disadvantage certain groups, and whether it's based on race or gender or wealth, for example. Once that bias is being baked into the algorithm, it's very difficult to get it out. So the issue of bias needs to be solved right from the beginning, even to the point of the diversity of the teams you're using to develop the algorithm as well, because you can create this blindness in the team that doesn't see the problems before it's too late. Another problem with AI that actually people don't really talk about that much, is not really realized, is this idea of the naivety of AI. So I'll go back to this example of being able to recognize a picture of a dog. Again, a picture of my dog here. And if you ask the AI to say, is this a dog or not, it would probably come up with saying, yes, it's reasonably confident this is a picture of a dog. But what you've got to remember is the AI doesn't understand what a dog is. It doesn't understand it as a human would, in that it's a living animal. We keep them as pets. We can love them. We take them for walks. All the things that humans associate with dogs, the AI will have no understanding of. All it's done is you've given it a photograph, which it converts into just a pattern of pixels to numbers, compares it to lots of other patterns of pixels that you've previously labeled dog, and says, yes, this pattern of pixels close enough matches that pattern of pixels. Therefore, I'm reasonably confident that I can label this the same label that the person has labeled it before, i.e. dog. That's all it's done. So it's just very, very clever maths. What we've got to be really careful of is that we don't anthropomorphize what AI can do and give it more credit than it's due. So at the end of the day, as I say, it's just very, very clever maths that we can use as a tool. So those are kind of some of the key risks of AI. So we've explained a little bit about what AI is, what it can do, some good examples, and what some risks are. So now you've got all this newfound knowledge. What are you going to do with it all? And I think the temptation for a lot of people is to jump in and say, well, how can we use artificial intelligence in our business? And I half jokingly say that prospective clients ring me up and say, can I have an AI, please? And these are clearly the wrong questions to ask. The questions you should be asking are, what are our business objectives? What are our challenges? And is AI an appropriate solution to help deliver and solve those? So we kind of have to turn that problem around. So one way of looking at that is, first of all, look at what your strategic objectives are as a business. So for example, they could be reduce cost base, reduce risk exposure, improve customer service, whatever they may be. You will know those better than anybody. And how you're going to achieve that. So no new hires, reduction errors, improving average handling time, various different things that you'll want to do to achieve your strategic objectives. And then you kind of need to come at it from the right to left side and saying, right, what AI projects can we do? What are these capabilities that I now understand can I bring in to actually impact one or more of these different activities that we need to work on? And some of those things will impact just one of those activities. Some will impact a number of them, and some of those activities just won't be able to be impacted by AI at all. But it's really important to understand that. And then also, what are the technologies we're going to be using out of that, and what's the overlap between all of those? So what are the common ones within the solutions that we're looking at? What third parties do we need to help us implement this? And then wrapping that around a plan to say how we're going to achieve it. So in very, very simple terms, that's the approach to kind of build an AI strategy. I'll explain a little bit more about how that would work. But you've really got to understand those benefits that AI can deliver. So these are kind of the main ones, I think. There'll be others, but if you can look at these ones as kind of the first ones. So customer satisfaction. Improve service quality, responsiveness. So we saw that with that Virgin Trains example. Cost reduction through use of less labor and process efficiencies. And we saw that with the tractable example with the insurance one at the very beginning. Risk mitigation, improved or comprehensive monitoring and assessment of risk. And we saw that with that Deutsche Bank example. Loss mitigation through maybe improved debt recovery or fraud detection. PayPal was a good example of that. Revenue generation through cross-selling, upselling, being able to offer new services that are enabled by AI. And I think the charity donations that I described earlier are a very good way of using AI to generate more revenue for them. And then finally, revenue leakage mitigation. So, for example, through reducing customer churn. And that call miner application, the call center, is a good way of doing that because you're providing better customer service at the point of contact as well. So AI can really impact a lot of different benefits. So the next approach as you're building an AI strategy is to identify all those different opportunities. And this is really where the meat of the AI strategy is. So looking at the opportunities, understanding the different technologies, how they're going to benefit your business, and then being able to prioritize those. So when I go into organizations, this is an example of a list. So there's typically between 30 and 60 different opportunities for AI across the board, across the organization. And we look at what AI technologies do we use, the benefits that it's going to bring those, and also things like ease of implementation. So some AI is going to be, we can do in weeks, some's going to take years to do. So through this, we can start to prioritize those, and then we can summarize them in what I call an AI heat map, where we can look at those different technologies, the different functions, departments that we're in, the benefits that it can deliver, and some of those other metrics as well. So by looking at this, we can very quickly see there's lots of prediction opportunities within the fundraising department. There are also lots of benefits within the research department, and we can see actually looking down the most popular technologies around the optimization space. So from this and looking where the benefits are, we can start to develop the roadmap of how we're going to do that. And typically a roadmap might start to look like this over the first 6 months. There'll be some proof of values within that, so those will be the ones at the top of that list of opportunities, how we do that. There might also be some things that we need to do to prepare for AI. So it may be that the data is not in a good enough state, or we need to do some organizational changes to get the right people in place. So the roadmap needs to take into account all of those to deliver the benefits that we've identified so far. And that AI strategy is really just the first part of this whole life cycle, but it puts you on a really good foundation for delivering sustainable long-term benefit from AI. So once you've done the AI strategy, as I say, you'll need to look at proofs of value. Once those are successful, then you can move to develop those, put them into production. And if you get enough of those, once that's in development, then what's next on the list of those prioritized lists, put that through the process, you start to build up this overall capability, then you might want to start to think about a managed service for AI within the organization. It's very important to see that this loop here of continuous improvement and optimization, because the business will change, the data will change, the models need optimizing, etc. So you've got to constantly have this loop of optimization within your AI structure. So as you move into that proof of value and development stage, you've got to think about how you actually get access to AI. And if you look at the vendor market as a starting point, that can be very, very confusing for people. And this is just some of those vendor maps that we've seen some analysts produce, and there's thousands of different AI vendors here, and some of them will be AI and some of them will be pretend AI. Some of them might even be out of business by now. So it can be very confusing for business people to start to look at this. So I think the best way to do that is think about actually what do we want to achieve with each of the applications that we're wanting to build with each of those opportunities. So I think of it as in 3 different buckets. So the vendor approach is very good, but only if the thing that the vendor can provide exactly matches your requirement. All the hard work's been done by the vendor, they've trained the models, etc., to a large extent, and all you have to do is pay your subscription fee and implement it, and you're away and you've got some good results. But you got to make sure it's doing the right thing for you. So selecting the vendor is obviously a big challenge. At the other end of the scale, you might have a bespoke data set, unique data set that nobody else has. You think there's an opportunity to do something that's going to actually change the market to give you competitive advantage. Therefore, you're probably looking at a bespoke solution, and that's where you need to bring in data scientists, developers, etc., to build that. It's going to take longer, it's going to be more complicated, but the benefits are going to be greater. So for certain applications, that might be the right approach. And then there's this kind of middle ground as well, which kind of I call configure, which is a halfway house between the vendor and the bespoke piece. And it's using tools like TensorFlow, like Amazon's Web Services, and H2O, of course, here. So we're using algorithms that are pre-built, data science platforms like H2O that do a lot of the hard work for you, and you just have to kind of build the application around that. And then, as I said, as you kind of build these out, then you're going to start to want to think about a managed service, your deployment platform. You're going to might need to think about data labeling, security, etc. So you're going to have to, build a kind of an ecosystem of different vendors, etc., around the model as well. So that's kind of as much as I want to say. I just wanted to finish off on looking at one slide in terms of what's next for AI. And I put a picture of a half-empty glass here, or a half-full glass here, because I'm an optimist, so this is a glass half full. And interesting, if you Google this, the internet seems to agree with me, because if you Google glass half empty, you get 8 million responses. If you Google glass half full, you get 64 million responses. So the internet is more optimistic than you might imagine. But I just want to finish off with one example where we can look a little bit into the future and see how potentially creative AI can be. So if you remember that example I gave you earlier, where AI was beating the best player in the world at Go, and DeepMind trained that on lots of games of human versus human. What they then did after that was develop a new system called AlphaGo Zero, which didn't use human games to be trained on. It just trained itself playing itself. So obviously at the beginning, as it's playing itself, it's very, very bad. But because it can play very quickly, it got better very quickly. And it started, I think over just a few days, it was as good as a professional player. But the really interesting thing about this is that the professional players that are watching these games going on saw moves that they would never have thought of playing. And because the AI was essentially unencumbered by the way that humans would have trained it, it's come up with its own solutions out of this. So the humans are able to learn from the techniques that the AI is coming up with. So you can think of this kind of the very early days of creativity, and how AI might actually help and augment human thought in the future. So that's everything I wanted to go through. I hope that's been useful, and I don't know if there's any questions. Ivan, if you want to let me know what questions that people have from that.
Yes, thanks, Andrew. We did receive a few questions. So let's start with the first one.
Sorry, my speaker stopped. You might have to say that again.
No problem. So the first question is, why now? AI has been around for a while now, so why should companies be deploying it now?
Yeah, that's a really good question. And I hinted about this earlier on in the presentation. I think there's 4 key drivers for AI at the moment. And this has been kind of prevalent since probably the beginning of this century. The first one is the amount of data that's around. And AI feeds off data. If there's no data, there's very little value you can get from AI. And what we've seen recently is just so much more data available, particularly through social media. So every time we post something, we create data. Every time we send an email, we create data. Every time we travel on the underground, we create data. All of this data can be fed into AI. But also as well, you need to store that data somewhere. So the cost of storage has come down dramatically, exponentially. It costs a matter of a few pennies to store gigabytes worth of data now. So previously, when companies would have been throwing away or archiving data, now they don't have to. They can just chuck it, and simplifying things, but chuck it into a data lake, and it's essentially available there for the AI to get some value through it at a very marginal cost. The third thing is the processing speed of computers. Again, something that's improved exponentially, through things like Moore's law. And this is really important for AI, because a lot of AI is a very iterative process. I say the machine's doing the learning, but the data scientist has to look at the beginning in terms of what data am I using, what features should I use, what biases and weights should I put into the original model, and that'll have a big impact on the outcome to that. So there's lots of iterations, and if you're using very, very large data sets, some of these iterations used to take weeks to do. So you might build your model, set it going, and then wait a week before you get an answer and think, that's not quite right, I need to tweak something, and then wait another week. Those weeks are now coming to days and hours, and in some cases minutes. So we can do lots more experimentation with AI as well. And I think the fourth element here is the connectivity. So basically through the internet, everyone's connected, so the flow of data is much greater. So we've got access to much more data. And what we've seen as particularly as well is access to publicly available data as well. So much more data is being made available through things like Kaggle. So some of those health applications, a lot of organizations can make their data available, so data scientists can pick that up and use that to train their models on. And some, although not a great example, those facial recognition databases, but there's better examples now in use, and words, pictures, etc., that are all available. So those four things: big data, data storage, computer processing power, and the connectivity, have already come together almost in this perfect storm now to enable AI to deliver to its full value. And I said earlier on, I think there's always going to be some constraint on everything. I think right at the moment it's around the cost of computing. So people can say, yes, we can do all this stuff, and really at the forefront of development, there's lots of really powerful computers doing some great things. Look at something like GPT-3, which is a text generation algorithm, but that's basically used the whole internet as its training ground. Uses an immense amount of power and costs a lot of money to run, millions of pounds per day to run some of these algorithms. So that's the only constraint at the moment. But if you look at some of the day-to-day applications that I've outlined in the presentation, those are cheap and, well, relatively cheap, and things that businesses can afford and can get really, really good returns on investment on.
Okay, great, thank you. Another question. So what are the biggest challenges that a company is facing when adopting AI?
Yes, I think the main one is that issue around data. One, if you don't have the data, then, as I say, there's little value that you're going to get out of that. There's some exceptions to those. When we look at chatbots, you don't necessarily need a lot of data to develop chatbots. But a lot of the kind of the data-led ones, if the data isn't there, then you're not going to get any value. But even if you do have the data, then it's got to be relevant data. It's got to be of a good quality. It's got to be in the right format. And a lot of work on any AI project is around this data wrangling piece at the beginning. What data do we have? Getting it into the right format. Cleansing the data as well, making sure that we're getting the right results, that the data isn't biased, etc. All those things are really, really important before we actually do the really clever stuff of doing the AI piece and using the algorithms, etc. So that's a real challenge. A lot of businesses, historically haven't looked after their data. I think that's changing now. People are starting to employ chief data officers and data scientists, etc. But that's the biggest problem. I think beyond that, you've got to look at some of these cultural, some of these softer aspects as well, beyond just the technology. So, AI is a very complex subject. It's not just a case of, putting in an enterprise system. There's those risks involved as well. So particularly if the senior management don't understand it, and particularly if they have some level of fear around AI, then nothing's going to happen within that organization. You have to get those people convinced of the benefits of AI, what it can do, and to make sure they understand that you understand the risks yourself and how to mitigate those. Otherwise, as I say, nothing's going to happen. So education, particularly around the senior management side, I think is really, really important, that people can see the benefits, because if they don't understand it, then they're not going to do it. So I think those are the main things, and then just generally, you'll be changing a lot of the ways of working, how people work. You're going to be augmenting their capabilities. You're going to be helping them in their decision making. so just the general change management aspects of it, like like you have with any IT project, are just as relevant with AI projects as well. You've got to think really carefully about how those come about.
Yeah. Okay, thanks. And what methods and techniques are best to identify use cases in a company?
Yeah, so I think, as I kind of outlined in the fourth part of the presentation there, it's really important to understand your business objectives and your challenges, and make sure that the AI that you're thinking about doing is value-led, i.e. it's going to actually benefit the company to achieve those objectives, or to meet some of those challenges that you have. And matching those two is a difficult thing. So that's why people typically come to people like me to do this. But having that basic understanding of what the capabilities of AI are, and matching that with your business objectives, is kind of the key piece of the jigsaw you need to get right. So if the business people don't have that basic understanding of what the capabilities are, then it's difficult to actually do that matching process as well. So I think that's the first part of that. And then once you start into the prioritization process, then, as I said, you could prioritize them based on business value it's going to achieve. So, for example, a lot of businesses have things like OKRs or KPIs, maybe 4 or 5 of those. So matching each of the AI opportunities against those and scoring them, maybe out of 5, you can start to build up, these are the most beneficial opportunities we've got. And then looking at other things like ease of implementation, and then you can start to prioritize those. So you can get, out of the list of 30, you can very quickly come to a top 5 or top 3 different opportunities. Where to start from. I think, and interestingly, as I was working with clients over the worst of the COVID crisis, hopefully that was the worst, we introduced another criteria of urgency as well. So a lot of clients were less worried about their medium-term AI strategy and more concerned about what can we do today to help us, help our business survive. So we looked at opportunities that would deliver benefits very, very quickly, more quickly than a lot of AI typically does. So we introduced this criteria of urgency as well, which was really interesting at the time.
Great, thanks. I think we have time for one last question. So how can small and medium enterprises use AI without a large in-house IT team or expertise in machine learning and data?
Yeah, I think it's a good question. Data scientists, machine learning engineers are expensive. They are difficult to recruit, and they're also difficult to retain as well. So, and typically with AI, it's not something you're going to need for a long-term basis. It's going to be, you'll have peaks and troughs as different opportunities come up. So a lot of people would look to external organizations, third parties for those resources. So, companies like Greenhouse Intelligence for those sorts of resources. And I think what you get then is, those challenges of retaining and recruiting the data scientists are somebody else's problem, and you just get the benefits of doing that. And, you can, as you go through, different types of opportunities, different applications, then you're going to need different skill sets as well. And also, I talked about vendors as well. So you don't necessarily need to have the data scientists in to build applications for you, or to have other data scientists come in. You could actually go to the vendor route as well and just bring those in, but you still need to have that kind of basic understanding of AI to make sure you're doing the right thing as well. Large enterprises, obviously, they have the budgets and the capability to bring in their own data science teams, and would generally just augment from external sources as well. But I think using some platforms like H2O from a software point of view, and external resource, I think is the best approach for now.
Okay. Well, thank you, Andrew, for taking the time today, and thank you to everyone who joined us. We hope you enjoyed the presentation. We have many other events in the H2O.ai agenda, so stay tuned and have a great day.
Brilliant. Thanks, everybody.
Thank you.